Hey there, I'm going to try to do a series of ecology lessons, Ecology 101, because ecology is so important and so beautiful and so fascinating, and this will be number 1. I hope to do 5 or 6 on this drive. My goal is to make them very short and also linear, which is going to be really hard in ecology, because one of the major components of ecology that makes it so fascinating and complicated and fun are these things called feedbacks, which I've talked about before. And feedbacks are basically just the expression of a network of interactions occurring that are the result, they're networked, like a spider web's net has little points of connection. So those little points of connection are, let's say, components in an ecological system. And if you pull out or pluck a hole in the spider web where that point of connection is, you literally have a hole. And so you've messed up that connectivity in the spider web. And if there was energy, just imagine there was energy passing through the strands, coming from those nodes and then going to another node, etc., then you would have basically interrupted the circuit of energy traveling through that network. And so feedbacks can be negative feedbacks in which that energy gets reduced as you are moving through the network, or they can be positive feedbacks in which that energy gets increased as whatever it is moving through that network of nodes or little points where the spider web is attached to increase the strength of those connections. All right. So because of these very important complex systems that are inherent to and integral to ecology, it's difficult to not go off on a tangent. All right, so my goal is to keep this short. All right, so ecology is the study of things that are living and non-living and how they impact each other, okay? And as a result of their impacts upon each other, these things called emergent properties arise. So that's like, if I go to, let's say you're in school and you have a close group in your advisory group. Let's say you have an advisory group. And you guys all meet the college counselor together, and you're a pretty close group. You've been going to school together for 4 years, and for whatever reason, you guys just really click. It's a really rare thing, right? But you guys just really click. Maybe you hang out after school, maybe you don't hang out after school, it doesn't matter. You know, or maybe this is a college group where you've just found, you're like people and you really click. And then, for whatever reason, one of those people leaves or a new person comes in, and something that you can't even put your words around or your finger on changes about the group. A lot of times maybe one group member will get married and have children, and the group starts to disintegrate. That is an emergent property, okay? It's a phenomena that's happening that it maybe is predictable or isn't predictable, but it emerges as a result of some little tweak in the system. And that system can be someone leaves the group, someone enters the group, someone has kids from the group, okay? These emergent properties, like I said, are the result of interactions, or can be the result of interactions between living and non-living things. And in ecology, we call those living things biotic components, biological, living, or abiotic, take away, living, non-living components. So what are non-living things? Well, it's like water, air, rocks. Rocks are incredibly important in soil development. Help me out here. All right, you guys come up with more. I'm not doing this all on my own. And then living things. Those are pretty simple, right? Mammals, arthropods, trees, microbes, etc. Amphibians. I always give amphibians short shrift. So feel free to call me on that. I would really like to start interviewing some of my friends who could fill in the holes that many in my knowledge base. Alright, so what would be an example of how living and non-living things impact each other? Well, I can't live without water, and I definitely can't live without oxygen. So I need trees around because they release oxygen. Breathe that in, my brain functions, my blood transfers that oxygen throughout my body. That oxygen is used to repair cells in my body, to make new cells. That includes brain cells as well as skin cells. And so my ability to think clearly and effectively is in some ways a result of the photosynthetic process that plants are engaged in. Okay, that is a wow. Well, if we want to go to positive feedbacks, what do I exhale as a result of my cellular respiration? I exhale carbon dioxide. What do plants utilize to make sugars in their bodies with that photosynthetic activity? Carbon dioxide. That's why plants and trees and using them to mitigate climate change is, for many of us, an integral part of addressing climate change. Not the only way to address it, but planting forests and preserving mature, healthy forests and mature, healthy urban forests is a critical component to reducing carbon dioxide in the atmosphere. Once we get control over the amount of emissions we are putting out. Can't really reduce right now because we're just emitting too much. Alright, so that's a really cool positive feedback. The more carbon dioxide that I breathe out, or the more oxygen, the more plants there are with, releasing that oxygen, the better the air quality for me. Maybe the better my physical activity. Maybe I'm going out and running and walking and doing more things because I feel good. That means more CO2 respired, and that's better for plants, right? Okay, so that's a positive feedback. Or at least a stable state. Maybe we should call that a stable state. Alright, before I go off on the tangent of states, which I'm not going to go off on, I am not going to do that to anybody. I'm just going to cut this video. Say it's done. It's over. And I'm trying to think out loud where to go next. So I've introduced abiotic and biotic. Maybe we will go to this thing called trophics.